Okay, continuing our review program, we're going on to Chapter 3 now. And in Chapter 3, you recall we were dealing with pairs of equations. And as background, we said one of three things can happen. If we were to graph one line and graph the other line, and they intersected right here, this would be a unique point, an ordered pair. Let's say it would be 2, 3, which would be a solution for both of those equations. That would be one unique pair. Then we said that another possibility was when you were to graph them, the lines were parallel, they had the same slope but different y-intercepts, there wouldn't be any point of intersection. So we said these were inconsistent and there were no solutions. And the third one was if we drew the first line and then drew the second line, and that was right on top of the first, then we said they were consistent, but there were an infinite number of ordered pairs as solutions, and we would write that as x comma y is such that you just list one of the equations. So this is sort of the background of what's going on as we look at this, and then we'll just give you some pointers. We're not going to do them all. And there were some parts of this that we didn't cover also. But looking at strategies, here they want us to graph this particular set of equations. Now, as I mentioned before, graphing is a little challenging because if you don't have graph paper, it's kind of difficult, but let's see what we can get out of this. So we'll draw a graph, and we'll 1, 2, 3, 4, 1, 3, 4, 1, 2, 4. Now in graphing this, we could use the X and Y t-chart, where we're going to solve for the X and Y intercepts. It's in standard form, so this is a good tool. So if x is 0, y is going to be a -5. If y is 0, this is a +5. So I guess I'm going to have to add a few more points. There we go. So 0, -5. 0, -5 right there. And then 5, 0, right there. Now again, I don't have a ruler, but let's see what I can come up with here. A line like so. Now this one is almost in slope-intercept. So what I need to do is put it in slope-intercept so I can graph it. So I'm going to go 3y, bring my -1x over there, and then my plus 1 there. So now I divide everything by 3. And I get y equals a -1/3 x plus 1/3. So my y-intercept is at 1/3, which is going to be sort of hard to plot, but how about putting it in the right place up here? That's about 1/3. And from that, I have to put in the slope, -1/3, so I'm going to go out 3 this way. 1, 2, 3. And that line is about right, so right about there. And then I'm going to go up 1. So up 1 about there. And again, if I had a ruler, I would say it's going to intersect about there. And what is that point? Well, 1, 2, 3, 4. That will be a 4, and it's down 1, -1. And I did that one pretty good, because that happens to be the answer. Okay. Going on to number 3 now. They want us to solve by substitution. And here, the pattern is to solve for one of the letters. So if I solve for x here, x will equal, I'll transpose the negative 2y over to the other side, it becomes a positive 2y plus 8. So there's a value for x. Now I go into the other equation, and where I have my x, I'm going to put this value. That's the substitution process. So it's 4 times 2y plus 8 plus 5y equals a -7. So I've solved for x. I'm now taking that value in terms of y, putting it where the x was. Now I have an equation with only one variable. So now I distribute to get rid of parentheses. This will be 8y plus 32 plus 5y equals a -7. Well, yes. And I'm going to work this out. So taking it from where we left off, we had cleared the parentheses, and I multiplied through. I now combine like terms. 8y plus 5y gives me 13y. I'm going to subtract 32 from both sides. That gives me a -39. I'm going to divide both sides by 13. And I get y equals a -3. Then using one of the equations, I could have used either one. I put my -3 value for y where y is. I put it in green so you could see it well. And we have a negative, well, x minus 2 times a -3 gives me a +6 equals 8. I subtract 6 from both sides, and I get 2. So my ordered pair then, and again, they have to be in this order, is 2, -3. Now, what I did is I left up one of the methods for solving the systems of linear equations. One was by graphing. Another method was by substitution, and we've illustrated those. But another method that's very good is by elimination. So actually, this is example number 5. It's the third method, but example 5 on this paper that I'm using. So step 1 in setting it up for elimination is to have it in standard form. And as I mentioned in earlier lessons, here's where you use a little bit of artisan judgment, strategy. You want to do something to one of these equations so that one of these letters, when you add them up, will be eliminated. So, what I'm going to do is I'm going to take this equation and multiply it by 3. Why? Because when I multiply this term by 3, it becomes a -3y, and these will cancel out. So what I'm going to do, keep this, and I'm going to rewrite this equation down here. So I have them still lined up. So 3 times 3x is 9x. There's my minus 3y. And this is important because sometimes students forget to multiply this last term, and that becomes a 12. Now, the key to this is this new equation that I have here is not the same as this, but it is equivalent. We did so by multiplying every term by 3. And now we put our line, add them up. This is 11x. These cancel out, equals 22. I now divide both sides by 11, x equals 2. So I now have the first member of my ordered pair. Now, let me just go over a couple of things here. If I were to do this, and the x's were eliminated, and the y's were eliminated, and I ended up with, like, let's say 0 equals 15, this is not a true statement. If I get a not true statement, this doesn't equal 15, then this would be a case where the equations were parallel lines and there would be no solution. We didn't get that here, but I wanted to go over that. And if we ended up with something such that 0 equals 0, everything's eliminated, 0 equals 0, these are the same equation. So this would be, again, infinite number of solutions, and they would write it as x comma y is such that it equals one of the equations, and they usually put that in a bracket like so. Okay? But that's not what we have here. That's just to illustrate those other situations that you might come across. We have our x is 2. So now we're going to go in here and go 3 times our x, which is 2, minus y equals 4. So this is going to be 6 minus y equals 4. I'm going to subtract 6 from both sides. So I get a negative y equals a negative 2. Now divide each side by a negative 1, or just change the signs, and I now have y equals 2. So that is my ordered pair for number 5. Now, I have number 6 up there for a special reason. Well, actually not. It's very similar to the one we've just done. Again, looking at it, you say, well, what do I need to do to get, let's say, the 10s to cancel out? Well, I have to multiply this equation by a 2. If I do so, then this term becomes a negative 10y. These will cancel out, and I'll write it down here below. So this is going to be 8x, 2 times 4, 8x. 2 times this gives me a negative 10y. And then 2 times this gives me a negative 8. Put my line there. This cancels out. I then get a 14x equals a negative 7. And as you see, we're not going to end up with a whole number. We're going to end up with a fraction. But that's okay, because you might get one like that. And we get then x equals negative 1/2. So we now have one of the members of my ordered pair. So x is 1/2. So let's use the first equation here. 4 times a negative 1/2. There's my x value. I'm putting it in there. The original equation. Minus 5y equals negative 4. All right, these cancel out, and this becomes a negative 2. And now I'm going to transpose my negative 2 to the other side. It then becomes a positive 2, and that leaves me with a negative 2 on that side. And now I divide both sides by 5. I get y equals a negative 2/5. So my ordered pair then is a negative 1/2 and a negative 2/5. And I think I did get the wrong sign here. Let me check here. Well, I'm dividing by a negative 5, so I'm sorry. That's going to be a positive, yes. Kind of lost track of my signs here. I had to divide by a negative 5 to get my y to be positive. So it's good to check your work. And again, those are the 3 methods. Solve by graphing, solve by substitution, solve by elimination. There will be some cases where by just multiplying one of them, you don't get something that will cancel out. So you have to modify 2 equations by multiplying this by something. And sometimes you have to change the signs, and you've done like those in the past. In this next one, it's a word problem, and we did some word problems, and I did a whole video on solving word problems. So let's take a look at this one. Here's a fella's in a boat, and they're in this river, and he's going downstream, in which the current of the river is 4 miles per hour, and it takes him 2 hours to complete this trip. Now, what we don't know is the rate of the boat. That's our unknown. And we're using the formula distance equals rate times time. So we know that going downstream, he went 2 hours. That would be time times the rate, which was his rate of the boat, which we didn't know, and the rate of the river, which is 4 miles per hour. So this is this distance of the trip downward. Distance equals rate times time. So this is rate times time. So this is the distance going downstream. Now on his return trip, the same amount of distance took him 10 hours. But he was going against the current. So there's our time, and there's our rate. But it's the rate of the boat minus the rate of the river. So again, we don't know that rate. But we know that this distance equals this distance. That is, distance equals distance, which is rate times time, rate times time. So I distribute, and I get 2r plus 8. 10r minus 40. Okay, kind of easy. And then now we're going to subtract 8 from both sides. This gives me a 48. I'm going to subtract 10r from both sides. That gives me a negative 8r. I'm going to divide both sides by a negative 8. And I'm careful with my signs. And I get the rate of the boat is 6 miles per hour. Again, this was in chapter 4 stuff that we did, or I should say chapter 3. And we'll be moving on to 4 shortly.